Welcome to impedance taper kit. Here we have two type of tapers, direct taper and differential taper. If we select direct taper, there is transmission line type, linear taper, exponential taper, Klopfenstein taper, parabolic taper, hyperbolic taper, and some other tapers also. So if we select any of them, suppose exponential, we have the details of the exponential taper given here. We have to select the impedance Z1. By default it is 50, and by default the impedance Z2 is 100 ohm. Here we have the electrical length theta in degree. It is 90 degree, which is basically beta into L. There is a design frequency f naught in megahertz. We have given this 900 megahertz. We can change this, like we can make this 1000 megahertz, and then we have to calculate. So this is the impedance variation along with the length of the taper. Here we have the minimum frequency range, maximum frequency, and number of subsections. There is S parameter variation. This blue line is S11 and the orange line is S21 parameter in dB with respect to the frequency range. And there is a group delay variation and transmission delay product. For each graph we can change the position of the graph by like panning. We can zoom into the graph by the zoom option. We can get back to the original thing. We can save this and compare this later. And there is the frequency range options. You can change, like 0 to 20 is already given. We can change this from 10 to 20 and then calculate. So we have the range, we have the plot for 10 to 20 gigahertz frequency. These are plots. And then we have the differential taper. We have three types of differential taper: triangular taper, lifted cosine left shift, lifted cosine right shift. First of all, we will go for the triangular taper. In triangular taper, these values will be given, and these are the theories. You can calculate. This is the impedance variation of triangular taper. These are the other variations, parameter variations: S parameter variation, group delay variation, transmission delay product, and variation of derivative of impedance. There is lifted cosine left shift. This is the variation of derivative of impedance, and this is impedance variation, S parameter variation, group delay variation, and the transmission delay product. Similarly, we have the lifted cosine right shift. This is the impedance variation. This is the S parameter variation, group delay variation, transmission delay product, and the variation of derivative of impedance. We can change this also. So the new impedance variation with this, and S parameter variation with this. In direct taper, there is error function. There is a factor, slope factor. We can vary the slope at the midpoint. Like this is the impedance variation. This is the slope for 0.1. Can change this like 0.2. The new slope will be changed. So we can change this to like 0.05 also, less than 0.1. The slope will be less. Then new parameters will be changed. We can change the frequency from 0 to 20, then again calculate. the impedance variation, S parameter variation, group delay variation, and the transmission delay product. Also, we have the logistic. This is the transmission delay product, impedance variation, S parameter variation, and group delay variation for logistic taper. Thank you.